Hello everyone, I'm Rishida Rakesh Kumar and today we are going to discuss about interrupts and interrupt hardware. So what do you mean by interrupts? Interrupt is nothing but a nuisance, disturbance, and we can call it simply as a abnormal termination. What do you mean by interrupts in computer organization? Condition or event that interrupts the normal flow of control in a program is what we call as interrupts. Basically, interrupts is a signal. Signal means signal can be generated from particular hardware or signal can be generated particular program execution. In simpler terms, an interrupt is a signal sent to the processor by either hardware or software, prompting it to interrupt its current operation and switch to a different set of instruction known as an interrupt service routine to handle the incoming event. So, interrupt service routine is nothing but to handle the interrupts and performs an necessary actions. So why do we need interrupts? Devices and programs occasionally need CPU services, but we can't predict when. So for the interaction with CPU, each device or a program is allowed to give interrupts so that it can be used as a signal to the processor. Need a way for CPU to find out devices or programs need attention. And why is it important to us? Because interrupts enable the CPU to promptly respond to the external events such as input from peripherals, communication requests from other devices, or software generated events. Without interrupts, the CPU would need to continuously poll or check for the events, leading to inefficiencies and increased processing overhead. Interrupts facilitate multitasking by allowing the CPU to switch between different tasks or processes seamlessly. Modern operating systems rely heavily on interrupts to manage multi-tasks concurrently, enabling users to run several programs simultaneously without interference. This concurrency is crucial for maximizing CPU utilization and overall system performance. In real-time systems, interrupts ensure timely responses to external stimuli. For example, in embedded systems used in industrial control, medical devices, or automotive applications, interrupts help in quickly reacting to sensor inputs, environment changes, or critical events by providing deterministic response times. Interrupts play a vital role in maintaining system stability or reliability in real-time applications. Interrupts facilitate communication and interaction between the CPU and external hardware devices. When a hardware device requires attention or has data to transfer, it generates an interrupt signal to the CPU, prompting it to initiate interrupt handling. This allows for efficient data exchange and coordination between the CPU and the peripherals, enabling tasks such as input or output operations, data processing, and device control. Interrupts helps reduce CPU utilization and conserve resources by allowing CPU to suspend its current task and handle interrupts only when necessary. Instead of continuously executing polling loops to check for events interrupts, enabling the CPU to remain idle until an interrupt occurs, thereby minimizing unnecessary processing overhead. This optimization is particularly important in resources constrained environments or systems with limited processing power. Now let's see what are the types of interrupts. So there are two types of interrupts, hardware interrupt and software interrupt. So what is hardware interrupt? If the signal for the processor is from external device or hardware, it is called hardware interrupt. These interrupts serve as a mechanism for hardware devices to communicate with the CPU and trigger specific actions or processes. When a hardware device needs the CPU to perform a task or handle an event, it sends an interrupt signal, prompting the CPU to temporarily suspend its current activities and respond to the interrupt requests. Hardware interrupts can originate from various sources, including input or output devices such as keyboards, mice, disk, and many other things. For example, when a user presses a key on the keyboard controller sends a hardware interrupt to the CPU to inform it of the key press event. Similarly, when the data is ready to be read from a disk or when a network packet arrives, the corresponding hardware devices generates an interrupt to notify the CPU. Upon receiving a hardware interrupt, the CPU performs several actions. It interrupts the execution of the current program or task. It saves the state of the interrupted program, including the program counter and register values, to ensure that it can resume execution later. It identifies the source of the interrupt and determines the appropriate interrupt service routine to handle the interrupt. It transfers control to the ISR, which is a specialized piece of code responsible for handling specific event or task associated with the interrupt. After the ISR completes its execution, the CPU restores the state of the interrupted program and resumes its execution from where it left off. Types of hardware interrupt. It is of two types, maskable interrupt and non-maskable interrupt. Maskable interrupts are interrupt signals that can be temporarily disabled or masked by CPU under certain conditions. It can be delayed when a much highest priority interrupt has occurred to the processor. Non-maskable interrupts are the interrupt signals that cannot be disabled or masked by the CPU and are always processed immediately. It cannot be delayed and should process by the processor immediately. Now let's know about what is software interrupt. Software interrupts, also known as traps or exceptions. It's a signal generated by a software program to request services from the operating system. Unlike hardware interrupts, which originate from external hardware devices, software interrupts are initiated by software instructions or system calls within the executing program. So, it is a type of interrupt that is caused either by a special instructions in the instruction set or by an exceptional condition in the processor itself. Software interrupts are commonly used to perform various tasks such as requesting OS services, handling exceptional conditions, or communicating with hardware devices through device drivers. For example, when a program needs to perform the file input-output operations, allocate memory, or terminate its execution, it uses software interrupts to request the corresponding OS services. The process of invoking a software interrupt involves the following steps, such as the program executes a specific instruction or a system call that triggers the software interrupt. The CPU switches from user mode to the kernel mode, granting the executing program access to privileged OS services. The CPU transfers control to the appropriate interrupt service routines associated with the software interrupt. Then the interrupt service routines performs the requested operation or service on behalf of the program. After completing the requested task, the CPU returns control to the program, which continues its execution. Now, let's know how interrupts are handled. Interrupt handling is a fundamental aspect of computer systems, allowing the CPU to respond promptly to external events and efficiently manage interrupt requests from hardware devices. When an interrupt occurs, it is identified by the CPU through dedicated interrupt lines known as interrupt request lines. These interrupt request lines are connected to the interrupt controllers, which manage multiple interrupt sources and prioritize interrupt requests based on their urgencies and importance. Upon detecting an interrupt signal on an interrupt request line, the CPU acknowledges the interrupt and determines the appropriate interrupt service routines to handle it. The interrupt service routines is a specialized piece of code responsible for executing specific actions in response to the interrupt event. Before transferring control to the interrupt service routines, the CPU saves the current state of the interrupt program, including the program counter, processor registers, and other relevant information to the memory. This ensures that the CPU can resume the interrupted program's execution later without losing its state. Once the CPU has acknowledged the interrupt and prepared the necessary context, it transfers the controls to the designated interrupt service routines associated with the interrupt. The services routines then executes the required actions to handle the interrupt, which may include processing data, communicating with hardware devices, or performing system level operations. Once the interrupt service routines completes its execution, control returns to the interrupted program and the CPU resumes its normal operation from where it left off. Throughout the interrupt handling process, the CPU ensures proper synchronization and coordination between hardware devices and software components, facilitating efficient communication and event processing. By responding promptly to interrupt requests, the CPU enables timely event handling, multitasking, and resource management in the computer systems, enhancing system responsiveness and performance. So basically, it consists of several steps. First, interrupt request. The device or the program sends an interrupt request to the processor. Second, interrupt service routine. The processor saves its current state and jumps to the appropriate interrupt service routines. Return from interrupt service routines. The processor returns to the point in the program where it was interrupted and continues executing. Fourth, interrupt acknowledgement. Once the interrupt service routine is completed, the processor sends an acknowledgement signal to the device or program to indicate that the interrupt has been handled. Fifth, interrupt unmasking. The processor then enables any interrupts that were previously masked. Here we can see how the interrupts are handled through interrupt service routines. Interrupt service routines. We already know what is interrupt service routines as it has high importance in interrupt handling. It is a specialized piece of code within a computer's operating system that is responsible for handling specific events triggered by interrupts. When an interrupt occurs, the CPU identifies the interrupt source, saves the current state of the interrupted program, and the transfers control to the corresponding interrupt service routines. The interrupt service routines then executes a series of action to address the interrupt event and perform any necessary task associated with it. They are often written in assembly language or low-level languages such as C as they require precise control over system resources and timing. They are crucial for managing interrupts efficiently, ensuring timely response to the events, and maintaining system stability and responsiveness. Interrupt priorities. Interrupt priorities refers to the order in which interrupts are handled by the CPU when multiple interrupt requests occur simultaneously or in close successions. In computer system, various hardware devices can generate interrupt signals to request attention from the CPU for tasks such as data transfer, input-output operations, or system maintenance. When the multiple interrupts occur simultaneously, the CPU must prioritize them to determine which interrupt to handle first. Interrupt priorities are typically determined based on the urgencies and the importance of its interrupt events. For example, interrupts related to the critical system errors or hardware failures may have higher priorities than the interrupts for routine tasks or background processes. Interrupt controllers, which manage interrupt requests from different hardware devices, plays a crucial role in prioritizing interrupts. They use mechanisms such as interrupt masking levels, or interrupt prioritization schemes to determine the order in which interrupts are serviced by the CPU. Additionally, some interrupts controllers support interrupt nesting or interrupt chaining, allowing higher priority interrupts to preempt lower priority interrupts when necessary. This ensures that the critical system events are addressed promptly even if lower priority interrupts are current being serviced. Overall, the interrupt priorities help ensure the CPU allocates its resources effectively, handling critical events in a timely manner while maintaining system stability and responsiveness. By prioritizing interrupts based on their importance and urgencies, computer system can effectively manage concurrent interrupt requests and provides a smooth and efficient user experience. Now, let's know about interrupt latency and real-time systems. Interrupt latency is the time it takes for a system to respond to an interrupt. In real-time systems where timely response to a critical event is essential, minimizing interrupt latency is a critical consideration. Interrupt latency can be affected by a variety of factors, including hardware design, interrupt handling software, and system load. Designing hardware and software that minimizes interrupt latency is a key consideration in real-time system design. Low interrupt latency ensures that the critical events are handled promptly, minimizing delays and meeting the timing requirements for real-time applications. By reducing interrupt latency, real-time systems can maintain responsiveness, accuracy, reliability, ensuring that the tasks are executed within specified time constraints. This is particularly crucial for safety-critical applications where missed deadlines or delayed responses can result in system failures, accidents, or loss of life. So, to minimize interrupt latency, several techniques are employed in computer systems. First approach is interrupt prioritization, where interrupts are assigned priorities based on their criticality, ensuring that high priority interrupts are handled promptly. Another technique is interrupt preemption, allowing higher priority interrupts to preempt lower priority ones currently being serviced, thus ensuring timely response to critical events. Interrupt masking is used to temporarily disable interrupts during critical sections of code execution to prevent interruptions and minimize latency, although it should be used cautiously to avoid missing important events. Additionally, optimizing the interrupt service routine code for fast execution and leveraging hardware acceleration for specific interrupt handling tasks can significantly reduce latency. In conclusion, interrupts and interrupt hardware are integral components of computer systems, playing a vital role in facilitating efficient communication between hardware devices and the CPU. By understanding the various types of interrupts, including their application and handling mechanisms, we gain insights into optimizing system performance and responsiveness. Prioritizing interrupts and minimizing latency are crucial aspects, particularly in real time systems, where timely response to events is critical as we continue to innovate and advance in technology. A deeper understanding of interrupts and interrupt hardware empowers us to design and develop robust and reliable computing systems that meet the evolving needs of modern computing. So I hope you guys understood the concept of interrupts and interrupt hardware. Thank you so much for listening.